Let's all go to the lobby. Let's all go to the lobby to get ourselves a treat.
Those ladies went crazy when Mick Jagger started yelling like that. What was that about, huh? Okay. When did time start moving forward? What then is time? If one asks me, I know what it is. If I wish to explain
a Roman
it,
bishop sits in the
him
window
who asks, I do not know. St. Augustine of Hippo, 397 AD.
his episcopal home on the North African coast. It is late afternoon. He looks out at the sun setting over the Mediterranean and watches the waves break along the shore, sand piling into disordered heaps. When the sun sets, it will be time to light the lamps if he wants to continue his work. He is Augustine of Hippo, theologian, philosopher, and
Funny hat
saint,
wearer.
famed for his 5 million words of writing that have survived to the modern age. He longs for the golden light to remain, for time to pause or even run backwards. What might that look like, he considers. The sun would rise from the horizon, not so different to the glory of a dawn. But all else would seem very strange. The waves crashing on the beach must collect and assemble themselves in a most unnatural fashion, with water droplets rising towards one another into a teetering pile before retreating back out to sea. It seems to violate the Lord's natural order, and Augustine shies away from the discomforting thought. What then, if he could witness time laid out before him, moving forward inexorably, from one moment to the next? The waves would crash unceasingly on the shore, advancing on the bustling town until it reduced his home to little more than a heap of rubble and sand. As his quill drips ink onto the parchment, Augustine's mind wanders to see time itself advancing, ruining all in its path, spreading its relentless chaos. The present world of man crumbles to meaningless piles. The thriving natural world eventually decays to nothing more than dust in the wind. And in the sky, stars wink out one by one until there is nothing left by which
Bro, St. Augustine, we're trying to have a date night here. Can we keep it a little lighter?
to measure the passing moments. With nothing more for time to devour, would this finally be the end of the voracious beast itself? What then is time, if not the inevitable march of disorder, the inevitable destruction of God's structured universe into nothing more than an eternal pile of sand?
Wow.
Shaking himself from the darkness of his waking dream, Augustine finds it truly is darkening outside. With the last glimmers of the setting sun, he breathes deeply and scratches out his final words for the day. What then is time?
What then is time?
But had Augustine really been able to see into the future and probe the minds of modern scholars, he would have seen that his dark imaginings were not only accurate, but substantiated by the highest theoretical physics and cosmology. The hungry beast of time, powered by ever-growing entropy, is unstoppable and relentless. It is driven not by some demon bent on destruction, but by the unassailable forces of mathematics that have gripped the cosmos from its first moments to its inevitable end. This entropy, bound up in the mathematics of particles and energy, powers the arrow of time, forcing our eyes forward into a future that is unavoidable as it is disturbing, and a past that is forever just out of reach.
Sold. Let's go. The entire history of the universe is going to be told to us in the next 29 minutes and 44 seconds. Part 1, what is time?
Some 1.5 millennia after St. Augustine found his words lacking on the subject of time, the industrial English city of Manchester was preparing to manipulate it.
Time started in
In the early
Manchester,
19th
Aaron was
century,
right.
timekeeping clocks were calibrated against local sundials, giving rise to times that could differ by as much as 30 minutes between the west and east coasts of England. But with the advent of the Industrial Revolution and the spread of the railway network, the country suddenly needed a unified system. Now, the difference of a few minutes between London and other stations on the network could mean passengers missing their trains or even collisions on intersecting tracks. And so, it was decided that, for the first time in history, time itself would be changed. In January 1846, the residents of Manchester collectively travelled through time, jumping 13 minutes.
Who made the first clock? Let's ask Domebot. Domebot! Okay, let's see. Let's ask Domebot, who made the first clock ever? Tell me in a paragraph. If we don't say that, fucking Domebot goes on forever. Who made the first clock ever? Tell me in a paragraph. Okay, Domebot is thinking, everybody. Can it read it out loud? Come on.
The cloak, one of humanity's oldest
did I
and
say
most
clock?
universal garments, has no single inventor, as it emerged. The cloak, one of humanity's oldest and most universal garments,
Oh my
has
God,
no
that's so
single
embarrassing.
inventor,
Well, I might as
as
well
it
learn about the
emerged
cloak,
gradually
too.
in prehistoric
I might as well
times from
learn
simple
about the
animal
cloak.
skins draped over the body for warmth and protection. Archaeological evidence, such as preserved
Thanks,
items
woke.
from Neolithic bog finds in Europe and the sophisticated leather garments of Otzi the Iceman. Who made the first cloak ever? Tell me
Okay.
in a paragraph.
Yeah, okay, thank you. Okay.
Who made the first cloak ever? Tell me in a paragraph.
Yeah, okay, stop.
Searching the web.
Stop reading, please. Okay. So we might have spelled clock wrong. Okay. Who made the first clock? There we go. Ever. Tell me in a paragraph. Oh my God, Mr. Rotella. What are we going to do with this guy? What are we going to do with Mr. Rotella? It's thinking. Domebot is thinking. Is Domebot an it or is Domebot a Domebot?
The history of timekeeping reveals that there is no single inventor of the first clock ever,
There has
as
to
the
be.
concept evolved gradually through various ancient devices designed to measure the passage of time more precisely than natural cycles like the sun or stars. The earliest known timekeeping tools were sundials, used in ancient Egypt around 3500 to 1500 BC,
Is that what an
which relied on
obelisk is?
shadows cast by obelisks or marked sticks to divide the day.
However,
However,
I'm
these
a
were weather
genius.
dependent, leading to the development of water clocks, clepsydras, by the Egyptians or Babylonians around
It is sun
1500 to
worship then.
1400 BC. These outflow devices allowed time measurement indoors or at night by tracking the steady drip of water from a vessel. Similar water clocks emerged independently in ancient China and Greece. Later advancements included more sophisticated geared or mechanical water clocks, such as those in China by the 11th century, but the true shift to fully mechanical clocks, using weights, gears, and escapements independent of water or sun, occurred in Europe around the late 13th to early 14th century, with no specific individual credited, though early examples appeared in Italian and German tower clocks. This progression reflects humanity's ongoing quest for reliable time measurement across civilizations.
I was right about the obelisk. Of course I was.
Go to the lobby. Let's all go to the lobby. Let's all go to the lobby to get ourselves a treat.
UFO Johnny says it's going to be the same answer as Cloak.
It's in an instant, as the town's clocks were adjusted to match the standard time set by the Royal Observatory in Greenwich, London. Although time had been measured for millennia following the passage of the sun across the sky, this was the first time it had been standardized, thanks to the incessant march of industry. But in truth, this so-called standard time is arbitrary, little more than an imaginary structure for our busy lives. The sun still sets in Manchester 13 minutes later than in London, regardless of the time on the clocks. And yet, the steam-powered locomotives of the Industrial Revolution did open our minds to the nature of time, in an altogether unexpected way. Some 20 years before England's clocks bent to the unstoppable force of the railway, efforts to understand the heat engines that powered these mechanical juggernauts led French engineer and physicist Sadi Carnot to make a prophetic observation. Steam engines had been quickly adopted across the rapidly industrializing world, bringing success and riches to all who embraced them. But little work had been done to understand how they really worked. This was the concern of Carnot when in 1824 he penned his influential Reflections on the Motive Power
To steam or
of
not
Fire.
to steam? That
His
is the
observation,
question.
which may seem simple and obvious now, was that heat always flows from a warmer body to a colder one. This explains how a fireplace can warm a cold room, why ice cubes melt when they're left in the sun, and why molten, newly formed planets solidify and cool in the cold vacuum of space. It is an irreversible natural process, and it is this that provides the motive power in all heat engines. In this, Carnot laid the foundation for the theory that was to become the second law of thermodynamics. This law was developed over the following century until it was brought in line with our evolving physical frameworks. Now, we recognize that not just heat, but all systems move in a single direction, one that will decrease the free energy of that system. Today, we describe this change in terms of entropy, a mathematical way of measuring the amount of disorder within a system. Specifically, it measures the number of possible ways that a large-scale, macroscopic structure can be created from its microscopic components. A train locomotive is a highly ordered structure. There are very few ways of arranging all the component parts to create a functioning engine, and so we say that its entropy, its measure of disorder, is low. A heap of wreckage in a railway scrapyard may have the same components as the locomotive, but piled on top of one another in a disordered heap. There are many ways of arranging the scrap to make the same chaotic pile. Because of these many possibilities, its entropy is by definition high. What's more, entropy always tends to increase. A functioning train locomotive, if left for long enough, will always become a disordered pile of wreckage. The chances that a heap of engine components will spontaneously group together and assemble into a fully functioning train are infinitesimally small. Entropy always increases. Everything tends towards disorder. So when coal burns in the locomotive,
Everything tends towards disorder. Don't we kind of feel that about society right now, just a little bit? I know I do.
engine, it changes irreversibly from a structured lump of energy-rich carbon to a disordered pile of inert
And it kind of feels like we're on this path that we can't really stop it, even though we would like to stop it, but it just keeps on going and going and going. That's where my mindset is about society right now.
ash, while its free energy is
And chaos
dissipated
is
into the
great
engine's
streaming.
boiler as heat. This fundamental property of our universe is not only the reason for steam power's success, but also
Woke says, bit like a marathon stream with family-friendly Fortnite. Every single family-friendly Fortnite, we hit about the hour and a half mark, and then that's when, like, I mean, once we hit the hour and a half, you never know what the heck's gonna happen. Slugger Ballyho, welcome in.
the basis for all of time itself.
Yes, Woke,
This
perfect.
unstoppable change in entropy in everything around us provides us with a way of distinguishing one moment from the next.
Part 2, the arrow of time.
It was just past dawn when Arthur Eddington began walking home through the streets of Cambridge. He'd spent the night peering up at the stars from the university's observatory, and his head was still filled with wheeling points of light as he tried to make sense of their celestial motions.
Been there, buddy.
Suddenly, he was pulled sharply out of his musing not far from the door to his apartment, as a stern-faced woman resolutely blocked his path. She held out a white feather, its soft, downy barbs catching in the morning breeze. He knew better than to resist. Taking the feather, he smiled politely and neatly sidestepped her.
Fat Kitchen invested $5.
Thank you so much, Fat Kitchen. Fat Kitchen says, end of the month late fee. Ballyho, Mr. Rotella. I appreciate that, Fat Kitchen. Hope you had a great Christmas, Ballyho. Folks, make sure that we're all here on New Year's Eve. We will start our New Year's Eve stream at 6. Go all the way to the new year in the free state of Florida. Please join us, everybody. Thank you, Fat Kitchen.
Later, just inside his home, Eddington shook off his coat, hung up his hat, and added the feather to the growing pile on the mantelpiece. It was 1917, and Arthur Eddington was a Quaker and a pacifist. According to
One second. Let me read this from Florida Pats, too. Florida Pat says, I don't know. I don't agree with that chaos theory totally. Things tend to want to find order, unify. What about the drip of water, a stream, etc.? I think things humans touch find disorder. Great chat right there, everybody. Ballyho, Elite Domer, Florida Pats.
That made him a coward. But Eddington was no coward when it came to grappling with the mysteries of the cosmos. He became a world leader in gravity and relativity. In 1928, he wrote an ambitious book that made the concept of entropy accessible to the layman for the first time. In it, he asked the reader to imagine the universal increase in entropy as an arrow, which can only ever point from order to disorder, from the past to the future. In this, he laid the foundation for the arrow of time, defined by the directional change in entropy from one moment to the next. As time moves forward, things become more disordered, and the passage of time is represented by this inescapable growth in cosmological chaos. The arrow of time thus describes why time must always move forward, why cause must precede effect, and why we can only ever experience it in that way. Time travel has become an immensely popular trope in science fiction, bending our minds with the paradoxes it creates. To travel backward in time, one must experience the universe in the unsettling improbability of decreasing entropy, of things spontaneously becoming more ordered. Waves uncrashing on a beach and backing away from shore, and heaps of wreckage self-assembling into functioning engines. Not only does it seem unnatural, but it violates the arrow of time that rules the universe and our own experiences. Even if one travels instantaneously backwards and then continues to experience time forwards from a point in the past, it becomes impossible to define a consistent, universal arrow of time. Theoretically, if we could find a way to travel faster than the speed of light, then through the mind-bending relationship between space and time, we would also be moving backwards in time. So says the mathematics, at least, but the reality is quite different. The speed of light is one of the most reliable, unassailable constants in the universe today. When we travel at the speed of light, Einstein's equations of relativity tell us that our mass rises to infinity, while our size shrinks to zero. Surpassing that breaks every law of physics we know of. Not only that, but by jetting into space faster than light and backwards in time, we would arrive at our destination before we had departed. We become trapped in a causal loop, isolated from the normal universe where, thanks to the arrow of time, a cause must always precede the effect. Stephen Hawking was so certain that reverse time travel would...
One second. Let me grab a beer. Gonna do a little Stephen Hawking, huh? Maybe a little string theory coming up here? Where multiple realities can live in the same reality? Can live in the same
Not be
time?
possible that he held a party on the 28th of June 2009,
Ballyhoe
for which he
Noah's Ark,
only
Ely
issued
Gomer?
invitations the following day. The only way a guest could attend was if they travelled backward in time.
Stream cheers.
Nobody
Big
made
guys.
it, and Hawking was left alone with 10 bottles of champagne. Travelling
there.
forward in time is another matter. It's easy. We do it all the time, experiencing 1 second of the universe for every second of our lives. We can even do it at an accelerated pace if we stray too close to a black hole and are gripped by the space-time altering forces of its enormous gravity. Skirting close to the event horizon of a rotating black hole about 8 times as massive.
Oh, 1 second. Noah's new, everybody. Noah's new to the dome. So every Friday night, Noah, we hang out and we do a Friday night date night. Welcome to date night. Are you wearing your tie, Noah? We watch a documentary based on stuff that we find during the week that we might want to learn a little bit more on. Tonight, we're watching about time because we have New Year's coming up. So we're doing an in-depth time evening. Welcome in. You're late, but, you know, time is relative.
As our sun, we can zoom forwards in time 60,000 times faster than our companions on Earth. We can jump forward 17 Earth hours in a single second.
17, it's happening.
The arrow of time dictates only the direction, not the speeds that one may travel. This directionality, sometimes called non-symmetricality of time, is an oddity that sits in contrast to most other physical laws within our cosmos. For example, gravitational attraction looks the same wherever or whenever you happen to observe it, and two particles in a gas behave almost like solid steel balls, conserving their energy and speed as they collide and rebound. These collisions would look the same whether played forward or in reverse. Thus, the arrow of time does not result from the movements of individual particles, as these are governed exclusively by the symmetrical laws of physics. The increase in entropy and the passage of time is not an inevitable consequence of our known physical laws, but it is an inescapable feature of the universe we inhabit.
That's not true, Aram.
Reconciling these two facts remains one of the great unanswered problems in physics. Some have even suggested that the very existence of time is an illusion, a consequence of our inability to perceive the world in all its detail. In the early 19th century, French philosopher and physicist Pierre-Simon Laplace contemplated the existence of an omnipotent individual, a veritable demon, who could know the precise position and momentum of every atom within the universe, and thereby calculate the nature of the cosmos for any point in the future or past. Could Laplace's all-knowing demon ever really exist? The symmetrical natural laws of the universe suggest yes, but entropy and time suggest otherwise. The irreversibility of time, created by the dissipation of energy and the increase in disorder within a system, makes it impossible to make such rigid predictions about the past or the future. What's more, on the tiniest scale, the universe is ruled by quantum mechanics, whose central tenet is one of uncertainty and fluctuation. Quantum uncertainty means it is impossible for us to simultaneously know the position and speed of a single atom, let alone all of the atoms in the universe. If we could, then the entropic measure of disorder would cease to have any meaning. Entropy itself would not exist, and neither would time. But this doesn't address the question of why there is asymmetry in the first place. Modern scientists have suggested that our ability to draw the arrow of time is a result of our
Woke says, could AI already be close to this on Earth? Question mark. You know what? That's funny, Woke. I was actually thinking about AI myself when they were talking about beating the speed of light. Could a computer program beat the speed of light?
Our
That's what I was
proximity to the Big Bang. Just as the concepts of up and down only have any meaning when close to the surface of the Earth, so it is our nearness, cosmologically speaking, to the beginning of the universe that allows us to orient ourselves in time. If that is the case, then the Big Bang must have represented a moment of extreme...
Because if CERN can create the Big Bang, if that's what CERN is about, if they're studying the Big Bang, wouldn't that get the atom particle up to at least the speed of light to create the Big Bang? I don't know. I truly have no idea what the fuck I'm talking about. This is just things that that pop in my head. I have no idea no one should listen to Mr. Rotella is what I'm saying. I'm just a guy that happens to know how to live stream.
Conditions from which the universe is still winding down nearly 14 billion years later.
Part 3, the beginning of time.
Ludwig Boltzmann never stayed in one place for very long. Throughout the late 19th century, he moved from post to post, in Vienna, in Graz in Austria, in Heidelberg in Germany, and in Berlin. In this, Boltzmann's personality mirrored the behaviour of the atoms that he studied, always moving, never ceasing, filled with unpredictable energy that could fling him in one direction or the next, from exalted joy to suicidal depression. Yet his mood swings did little to dull his scientific fervour. He was a pioneer, ahead of his time in his atomic vision of the world, developing an entirely new field of science: statistical mechanics. With this, he created a framework to understand the unceasing growth of entropy for the first time.
Elite Over Kara says, professional streamer, yes. Physicist, not so much. Well, hey, we don't know that yet, Kara.
Simplistically, he imagined colliding particles as balls on a billiard table. The physics and geometry of the collisions are predictable, providing you know the speed and angle of impact, and the usual natural laws apply. But the more collisions there are, one after the other, the more disordered the table becomes. It becomes increasingly unlikely that the continuing collisions will result in an ordered pattern. Not impossible, but spectacularly unlikely. It might happen once, but to travel against the flow of time is asking it to keep happening, and is against all the odds. He argued that the second law of thermodynamics, and by extension the arrow of time, was a statistical necessity, a result of the fact that disordered states are much more likely than ordered ones, even in a world governed by uncaring, symmetrical, natural laws. Tragically, under a barrage of criticism for his mathematical treatment of existence, he committed suicide before his theories could be proved correct.
Time didn't see
Today,
that coming.
if we visualize the universe as an infinite billiard table, then the ever-growing entropy that defines the arrow of time shows that we are still within sight of the beginning of the game. The universe must have begun with a higher degree of order if we are still statistically approaching randomness. But, based on what we know about the earliest moments of the cosmos, this seems counterintuitive. A homogeneous soup of protons and raw energy at first glance seem much more random and disordered than the stars, galaxies and humans that exist today. How could a uniform universe have lower entropy than the organized one of the present?
Elito Murnoa says, do you believe in the multiverse, Mr. Rotella? I wonder if there's, I don't know if I believe in it, Noah, but I'll go as far as saying that I wonder if there's a Mr. Rotella out there where everything always went right for the guy. And I wonder, I wonder on major life decisions, major life choices, major life interactions that went a certain way, and if they would have went a different way, where would that Mr. Rotella be today? So I do think about that, but I don't know if there's multiple, if you're asking, do I believe if there's multiple realities? I mean, I can barely handle this one.
It is, in fact, possible to calculate the entropy of the early and modern universe, using the so-called Boltzmann constant. At the Big Bang, the entropy of the compressed, radiation-filled baby universe was by no means low. It was 10 to the power 88 times the Boltzmann constant, a 1 followed by 88 zeros. In contrast, the entropy of the universe today is a 1 followed by 103 zeros, some quadrillion times higher. So the entropy of the universe has indeed increased, but the starting point was not as low as we might imagine. It turns out that the order that we humans are so attuned to actually has very little impact on the overall entropy of the universe, and 14 billion years of time has barely changed the entropy of the background radiation that's been there since the beginning.
Aram says, is there an Aram out there with hair?
Entropy has increased by a factor of a quadrillion because of the addition of one particular structure.
Many.
Black holes. These mysterious objects that reside at the center of galaxies and which are lurking darkly elsewhere throughout space are the result of vast amounts of matter being packed into a small space.
Chat is on fire tonight. As always, Woke says, Aram and one with tits. Not only does Aram have hair, but there's a universe with Aram with tits.
They contain so much matter, so many particles, that there are almost limitless ways those particles can be arranged to still create the same massive, lightless hole in space. This alone is enough to make a significant impact on the entropy of the entire universe. The black hole at the center of the Milky Way galaxy alone has entropy that is 1,000 times greater than the entire universe just after the Big Bang.
I did not know that.
With time, natural physical laws of gravity will drive the creation of more black holes and cause existing ones to grow, driving the entropy of the cosmos ever higher and driving time's arrow forward relentlessly. But not, as you may think, forever.
The amount of things that the amount of coincidences that brought Mr. Rotella to where I am talking to you, UFO Johnny, are astronomical. So, I mean, who knows, man? Who knows? There's no way in the world that I should be talking about politics online right now. I've never in my life did I ever set out to do what I'm doing right now with you guys. So, who knows? Part 4, the end of time. I'm sure this will be light and very nice to hear.
The heat death of the universe will see all energy evenly distributed across near infinite space. For now, entropy continues to increase inside black holes, and the disorder of the universe as a whole gradually grows as time's arrow flies ever forward. But one day, trillions of years from now, black holes will have swallowed every last particle in the cosmos.
Oh, nice.
And they themselves will have evaporated away.
Thanks,
Nothing
man.
can survive this inevitable end, when all energy and matter is no more.
Nolan's
overall,
the best,
entropy will be as large as it is possible to be.
Funny.
A white noise of randomness in ultimate equilibrium.
What's up, JDL?
And since time cannot flow backwards, it will stay that way forever. Without any change, time ceases to have meaning. This truly is the end for time. A cold, black, empty universe existing outside of time and space as we understand it. But it would be wrong to assume that nothing happens in this empty universe. Entropy might have reached its maximum value, but that only means that there are a near infinite number of ways that the universe can be arranged.
Oh my God, it's blowing my mind and I love it. Elidummer JDL says recovering from surgery. Recovering from surgery, my friends, and watching the dome. Everyone give a nice ballyho to JDL joining us tonight. Probably hopped up on Vicodin, enjoying the documentaries about time.
Physical stuff of the universe can fluctuate through these random permutations, and so the entropic equilibrium is a dynamic one. The universe as a whole may not become any more ordered, but statistics suggest that small fluctuations could create pockets of organization at random. When tossing 100 coins, it's extremely unlikely that all will show tails. But it's not impossible.
Entirely impossible.
And since this most random universe at the end of its life is effectively eternal, there is plenty of opportunity for random tosses to give any result you can imagine. Modern physicist Sean Carroll has used this principle to write a potential origin story for our own cosmos. Suppose a universe has lived its life and met its entropic end many billions of years ago. The result would be an unchanging, timeless parent universe with random local fluctuations in entropy. One of these fluctuations might just configure its energy in such a way as to create a highly compressed pocket with inexplicably low entropy. A baby universe, with the billiard balls figuratively set, ready for the first break. This, Carroll argues, could be the beginning of our Big Bang, and the beginning...
Wow, how long are we, each of us, when I say we, each of us, how long are we in our pool game? How much randomness has happened from everything being the same start to where we are now? That's a great thought right there for me. Elite Dimmer Wokepotamus says, I've met plenty of random tossers in my time.
Of our arrow of time, created as a hiccup from a timeless parent. The idea seems compelling and seems to fit neatly with some cyclical origin stories. But it also raises a strange and disturbing possibility. An aged parent cosmos that can create an entirely new baby universe can also use its limitless coin tosses to create pretty much anything else we might imagine, including more of us. And new us, as opposed to entire universes, require far fewer coin tosses. More specifically, bodiless human brains drifting alone through space. This so-called Boltzmann brain, named after Boltzmann's work, is part of a thought experiment that looms over our current theories of eternal maximum entropy.
There's just brains out in the
universe? It seems vanishingly
universe?
unlikely that a cold, empty universe could create a human brain, replete with thoughts and artificial sensations and memories, but it truly is one of the permutations that the maximally disordered cosmos can cycle through. Given enough time, this seemingly impossible permutation could spontaneously appear. Given an even longer amount of time, it could happen over and over again. Given the eternal end to our universe, statistically speaking, Boltzmann brains are inevitable. And in fact, in purely statistical terms, actual humans, with the added complications of physical bodies existing in the actual universe when it is nearly 14 billion years old, are vastly less likely than Boltzmann brains.
Yeah, how the hell are
in
we
an
even
empty
here?
universe that has been cycling through random permutations for hundreds of trillions of years. It follows that, statistically, our thoughts and experiences are much more likely to be an illusion of a fictitious universe conjured by non-corporeal Boltzmann brains than they are true reflections of the cosmos so close to its birth.
Loved it. Are we done? Is that it?
Of course, physicists don't believe that this is really the case, and the goal of modern cosmology is to find a theory that does not threaten our existence and create
Oh, you mean they don't think that there's floating brains out in space? Thank God we brought it up.
a timeless eternity filled with dreaming horrors. If we really are here
That's Bourbon
experiencing
Street.
the universe at nearly 14 billion years old, then the idea that the universe
I
will
was there
exist
for
forever
WrestleMania.
in timeless stasis must be wrong. We need a theory that will produce a definitive end to space-time before statistics has the opportunity to create Boltzmann brains.
The answer is
to
42,
outnumber us.
Shaka. It is. I know exactly what you're talking
There are
about,
possibilities being actively pursued at the very bleeding edge of theoretical physics. A contracting universe that leads to a big crunch and rebirth, multidimensional string theory brain collisions wiping us out. The search continues in hope. And so, St. Augustine could not have known how right he was when he wrote that time
Shaka. Woke says the point was that we exist in the imagination of a floating space brain. Well, I mean, anything makes sense to me, man.
evades
I like it.
definition. Arthur Eddington could describe the arrow of time, but he couldn't truly comprehend it. Boltzmann, for all his troubled brilliance, only created a statistical demon that continues to threaten our reality. And even today, modern physicists have no definitive explanation for the beginning or end of time. Which raises the grim thought. Perhaps all of these Influential minds were really no more than that. Minds floating aimlessly through space, dreaming of a universe they could almost understand. And yet more likely, perhaps our own memory of these scholars is a fiction, concocted by our single Boltzmann brain, drifting in an eternal, timeless universe. Or perhaps, sometime sooner, theoretical physics will find the answers we seek. For the sake of our reality, we can only hope that it does.
Loved it. Really looking forward to what's next.
You've been watching the entire history of the universe.
The entire history of the universe. Next is gonna blow our freaking minds. Not only with the content, but with the narrator. We got Morgan Freeman coming to the dome, talking to us about time, space. We're going through wormholes. And it's not Dune. Florida Pat says 6 times 7 is 42. I love 42, man. 42. I love Hitchhiker's Guide to the Galaxy. I think yeah, don't panic right there. You know, it's been so long since I've gotten these tattoos, I don't even know what's on me sometimes. That is the truth. What the hell, like, what, it's been, I don't even think about them anymore. It's very true. Number Aram says, Woke, that's very interesting. I've never seen that movie, but I probably should. Hitchhiker's Guide to the Galaxy. Oh my God, it's great. Aram, do you know how to read? Read the books. They're hilarious. They are hilarious. Full, is it a 5-part series? 5-part series, but they call it a trilogy. The 5th book in the trilogy. I always thought that was pretty funny on the cover. Very dome. Hitchhiker's Galaxy is very, very dome. Florida Pat says, Mr. Pat says it's a great movie too. Campfire Starter says, never heard of that movie. Campfire, give it a try. It's good. The movie, the books, I got a tattoo of it, so it's very, very good. Florida Pat says, Mr. Rotella, do you know how to read? Really? Says Florida, I know how to read. Just when I say things out loud, they get jumbled up. There is an old TV series, Woke. I've never watched the whole thing of it, but I've definitely watched some of it. Campfire Starter says, love reading, getting the books for my library. Bam, Campfire Starter. Hitchhiker's Guide to the Galaxy was actually one of the first books that ever made me laugh out loud. So it is fantastic. It is fantastic. Okay, when we return, Morgan Freeman taking us through wormholes. Stick around, my friends. Our main event coming up next.